X-ray, one of humanity's greatest achievements, used in medicine, astronomy, crystallography, etc. So if you're getting this, I'm about to have the most stupidest idea ever. I'm going to make an X-ray tube. As ridiculous as it may sound, I'm gonna be making one for myself because I've been fascinating with this kind of radiation, since I can make from radio waves to UV light and all that using a high voltage. But I've always wondered, I want to reach the limit, if you know what I'm saying. So I'm gonna be trying to make an X-ray, which is a new type for me, and not a lot of people can do it. So I will. But mind you, this attempt, is definitely dangerous, and you should really be careful what you're doing, and you gotta put in a lot of research, and, generally be careful because this is radioactive. Even if it's successful. What is an X-ray? X-ray is a high energy radiation, electromagnetic radiation. But anyway, this X-ray is mainly found in very few places. For example, our sun, the stars that generate enough atomic or nuclear plants can also create this kind of X-ray. And lastly, is in hospitals. One of X-ray's properties is, it can penetrate literally anything. It can penetrate through human skin, metal, any type of material. Alright, enough about X-rays. Now, how can I produce an X-ray? I already told you that I must make something called an X-ray tube. An X-ray tube is a simple vacuum tube, which contains an anode and a cathode. One that releases electrons and one that receives electrons. Now, this X-ray is generated. A high-speed electron will collide at something. The electron loses its energy and it becomes slow. But that energy must go through somewhere. See, according to the internet, there are two types of, X-ray tubes. The one, we call it a hot cathode tube, and the other one is the cold. The hot one uses a filament. That hot filament will create a free electrons, and that electrons will be accelerated using a high voltage, and then those electrons will collide with the anode, and that anode will generate an X-ray. But what I'm gonna do is the second one, since the hot filament one is very difficult to do. It heats up and there's a lot of issues. But the easiest one and the oldest one is the cold cathode ray tube. That is simple. You find a vacuum, you make a vacuum, very almost, and then you put two electrodes on two sides. And congratulations, you made an X-ray tube. For example, you're gonna use this, a cylinder, a syringe, plastic cylinder. Now what we're gonna do is, we're gonna insert some electrode here, and then we're gonna, quote unquote, suck it or plunge it down. Now, when that happens, there's almost no air inside. It's just empty space. That's vacuum. That's what we need. Okay, here's what I'm gonna do. I'm gonna use a hot copper wire, and then I'll insert it until it pierces the piston. And then when that happens, I'm gonna clip it, and then I'm gonna separate it. Now, there's some kind of... Okay, just let me show you. Okay, if you can see it right there, first I inserted a hot copper wire inside, and I wanted it to pierce the piston. And then, after aligning it perfectly, there's some epoxy in the cylinder, but I don't think we have to worry about it right now. And then I made epoxy at the holes so it doesn't leak. And now I think it's perfect. I think it can make a good amount of vacuum. Yeah, if I let it go, it will just go in. Hold. Okay. This wire, the wire that I've inserted here, is an anode. And I'm gonna make a cathode here, and we can successfully make a quote-unquote vacuum chamber. Okay, okay, what I did here is attach a nail, a big nail, and I sucked it, and I, made a stopper here. so it will stay like this regardless of the, well, regardless of the vacuum pressure. Now, mind you that this thing look, well, really good to be honest, but I'm not guaranteeing any, well, results. I'm gonna be honest with you. This is some kind of a trial and error thingy. Now, the problem is when the initial, the top, the place that the piston was here, there was some very minute air. Well, that's a mistake because there must be no air. It must be very little amount, but that amount is very microscopic. So we need to assume that it is completely sealed and completely no air. But the problem is I can't remove the air because there's some kind of gap inside. Yeah, it kind of sucks. Yeah, it kind of sucks, but it might produce an X-ray according to my, well, brainstorming. It might create an X-ray, but I'm not sure. It's like 50-50. To be honest, 50-50 is more than the average person can do. Almost nobody can make an X-ray. But in my case, I can make 50% chance. It might make some kind of a very, 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 very small amount of X-rays. And also, I got one more problem. The most essential one. How do I know even if I'm making an X-ray? I need a detector of some kind. That is when I got into trouble. You see, to detect an X-ray, I need one of the three materials. An X-ray photography, well, the thing that they scan bones back in the day, yeah, that's the problem. It was back in the day. Now it's all digital. And I don't have a digital X-ray detector, you know. I don't work in radiology, dudes. Come on. Yeah, I don't have a detective stuff. And the second one is using a Geiger counter. You know, this thing. Yeah, the Geiger counter, I don't have it. But maybe in the future, maybe I'm gonna make my own Geiger counter. Maybe, just maybe. And also, the third one, I need some kind of a material that is called, I call it fluorescence. I need a fluorescent material, like a urine or some kind of paper or some, but the problem is X-ray is so energetic and it might not even work on fluorescent materials. So I told you, this is like 50-50 chance. This is the closest, I think this is the closest that I can ever get in creating X-rays. So, well, this thing is for you guys and I've attempted it. And if you guys can make it more than me, please tell me in the comments. But also be careful, X-ray is dangerous. Okay guys, I've made the room a bit darker so you can guys see what's happening right here. And it's kind of scary holding this thing because, as I told you, there's 50-50% chance that this shit is producing X-rays that is creating cancer cell right now. So yeah, this is for you guys. Now, watch. What the? Do you see that? It's some kind of plasma. Whoa, that is cool. It's some kind of light purple. And also it might be producing X-ray, so you got this, right? Ooh, it's kind of getting warm. Okay, the entire cylinder is getting warm. That's not good. I don't have to, do this over and over again because the thing will melt. Okay, it's kind of a vacuum chamber, As I told you guys, there's some kind of residual air inside. And there's some kind of residual air inside, so yeah, that is a problem. I told you guys that it may not work properly because this is a DIY of a DIY, if you know what I'm saying. But it kind of looks cool. Yeah, the thing inside, it's air getting ionized. And it's creating, for example, it's creating about UV, IR, visible light, which is violet color. Even if it might be creating X-rays, but there's no telling. That's kind of cool, though. It's kind of cool. And to be honest, And also, to be honest, the device is the cylinder is kind of vibrating. I think it's because of the frequency or something. Whoa, what is that? Yeah, it's kind of a plasma inside. That's kind of cool. Well, guys, it turns out that instead of making an X-ray, I made an elaborated, quote-unquote, version of my vacuum chamber of, well, previously from my video. So yeah, this shit is garbage, I think. But at least I tried to make an X-ray closely enough, even if I've kind of failed. Well, I kind of not call it a failure because 50% of chance, and I have no telling. Anyway, yeah, well, this is what a homemade, very, very cheap, probably in terms of less than $1, maybe, I don't know, an X-ray or a vacuum tube, whatever you call it. And well, tell me your comments on down below, okay? And thank you for watching. See you next time.